Okay, hello everyone, welcome to this session, number 300 afternoon, and I will check the Twitch. What is my channel? Here. Okay, we are online. Got it. Okay, in the morning we were check this this problem. Basically, this is the solution, but I would like to check the solution, iterative solution. What is that? Is this? Yeah, the iterative solution. Yeah, I would like to understand this. No. If I copy this, yeah. We have this, and we can copy here again without any. Okay. Yeah. One moment, please. Okay, I'll be back. And okay, this is our code, our test, and it's time to use this tablet. Okay, now okay, the idea is receive the root. The root in this case is the number 1. Yeah, in this case receive the 1. Okay, current is equal root, null, null, null. Okay, while current is different to null, in this case is 1. Okay, apply this operation. Current dot left it's equal next. In this case, this is currently this is the root, and this is the structure. Yeah, and is next is equal current dot left, means that is 2. Okay, and in these swiping nodes now need to team to create. Okay, and current dot left, that current is this dot left, it's equal temp, means that is null. Yeah, here disappear, and okay, current dot left it's equal null. Let me put here null. Okay, and temp it's equal current dot right. Okay, temp now have the value of 3. Okay, this is 3. A current dot right, this it's equal to prev, that in this case prev is null. Yeah, here is null. Basically is disconnect in both the both children are a disconnect. Null, and prev it's equal current. Prev in this case is this, it's equal current, that it's 1, and current it's equal, let me check here. Okay, it's equal next. In this case next is null. No, next is equal to, yeah, and now current have the value of 2. Okay, next is equal the number 2, we are here, and is next it's equal the left, in this case is the 4. Okay, current dot left it's equal temp, that temp is current dot left is null. In temp it's equal current dot right, in this case temp it's equal current dot right is 5, and current right it's equal pref, that in this case pref is 1. Okay, and continue. Yeah, the question is a little tricky. Okay, we can move to another. Okay, to another problem. Okay, problems. LeetCode. This. Oh, it's unlocked the. Let me check the cache again. Okay. Okay. Increase the triple subsequence. Pointer is done. This is done. Linked list. Delete node in binary search tree. No, this is binary search. This is very interesting question. The cocoa eating bananas. I remember was a very funny. Yeah. Binary search. Find the big element. Well, we can. Oh. Okay. I don't remember the solution, but we can try. Find big element. Big element. A big element is an element that is strictly greater than its neighbors. Given a zero index integer array nums, find a big element and return its index. If the array contains multiple peaks, return the index to any of anyone. You can imagine that nums in the index less 1 it's equal nums in in the index less 1 is equal nums in the index n, it's equal less infinite. In other words, an element is always considered to be strictly greater than a neighborhood that is outside in the array. Okay. Yeah, basically the first always is considered greater because the previous doesn't exist and is basically less 1. And the last is greater because the last don't have more element to the right side, and we can consider it is less infinite, you know. Okay, both sides, the first and the last element, are greater for this consideration. Yeah, you must write an algorithm runs in logarithm n time. Okay. Sorry. 1 to 3, 1 in the output is true, 3 is pick an element, and your function should return the index number 2. It's enabled. Okay. 1, 2. This case should go have. We have this. Your function you can return either number 1 where began. Research. My first idea is start. Let me copy here. Here. Okay. And my idea is that start here and start here, and obviously validate, and in this case, for example, it's okay, and return 1. You can return any value. Yeah, and basically no, but this is n because on the final you should move for all the array. No. Yeah, the first is that check this element, next to is move with the next, and validate this, and this, validate this, and that's it. But forget this solution in this time. I'm not sure. I tried it before. No, we told me it. We can use, for example, this start in a half and validate. For example, this is greater, the 3 is greater than 1, and 3 is greater than 5. Yeah, basically this is the operation. With this, in the case that happen, for example, yeah, for example, 3 is greater than 1, yeah, means that we have this subarray until this moment is okay. Yeah, and in this case don't make sense that still with this comparison because it's not possible. No. 3 is greater than, yeah. One moment, please. Okay, I'll be back. Sorry. Uh, okay. Now, yeah, this is my idea. Using the half of this element to discover where is the right answer. For example, again here, let me use two different colors. The first and this, yeah, yeah. For example, you have the number 3. Currently, we have 3 colors. Okay, now this is with black. We are here. Okay, we are here. The idea is that take this element with the previous. Now, this element and ask one it's minor to 3 and 3 is greater to 5. In this case, for example, 3 is greater than 3, yeah, and here is grown, okay. And for example, if we start here, we can move to the right, because in this case, for example, it's impossible, yeah, it's impossible that this substring will be right, because it's impossible, because we know that in this moment that it's not possible only for this. No, but let me check. Oh, sorry, let me check. You imagine that no, no. Okay, I feel that I am in the right path, but okay, let me try again. We are here in the number 3, yeah. Okay, now 3, 1, and 5. Okay, now if we take this substring, we should get this result. 1 is minus 3, yeah. 3 is greater than the less infinite, yeah, because in this case mentioning this, an element is always considered to be strictly greater than the neighborhood it's outside the array, yeah, for the reason appear here. in this case, for example, is it's valid, and we can return, for example, this position. Yeah, no, no. We are wrong because we have this value here. In this position, this rule only happened in the 4 and in the 1. Yeah. Okay. Let me come back. And okay, we'll start here. Okay, we are here. Okay. Now we can take this 1, 3, 5. Basically, it's as the operation. 3 is greater than this, is greater than this. What is the for this side? It's this is greater, yeah, and for this the result is wrong. Okay, means that we can move. If I move to this, and for example now it's 1, 2, 1, 3, and we are here. Yeah, we know that this value I think that it's only apply this operation over start here and ask this, and where the operation maybe I should use a recursion for this, but for example when is true when the previous value is minor to the current value. Yeah, when happen this we can get all this substring 1, 2, 1, 3. When is wrong, we basically we can start in this, discard this this value. Yeah, and for example in this case when next is greater than current, let me change current it's minor to next. When happen this, the result should be, or the rest should be have this. Yeah, and for example here we have this, and now here. Now if we have the half of this element is 2, and when happen this conditional, when both are true, we can return the index. Yeah, for example in this case the index is the index 1, but imagine that this is for example 4. Okay, it's wrong. We should move to the left. In this case is here, and this is less 1. It's greater than this, but not that this. Yeah, in essential, until this moment I had the idea to, if obviously if both are true, yeah, if our current element is greater than the left and the right, yeah, return index, or return current, sorry, current. Yeah, in this case suppose that it's a 10. Okay, it's greater, okay, return it, that's it. But when it's false, because the previous is minor to current, yeah, for example we are here, the previous is minor. Okay, this take these values, yeah, of this substring, and apply again the operation. When the current it's minor to next, only move the pointer to the next element. In this case, for example, is here, and take this substring. Yeah. Okay. Let me try to do here. Okay. Now we should use the index. Now integer L it's equal 0. Integer right it's equal nums.length. Integer width it's equal R less L between 2. And here is basically a while. No, it's not a while. Here return find peak element, and this function, it's a function that return a boolean and receive private boolean integer find big element. In this receive the array complete integer L integer R, and the mid is calculated inside. Now here integer L, in this case the L is basically 0, R is this, and nums, and we receive, for example, this, and in this case is calculate mid. Well, in this case mid don't make sense, have here. I can calculate here, and we should in this case we have mid. Let me create the variables only for don't lose the reference for more clarity, but integer mid val it's equal nums in the index mid. For example, in this case should we have this 0 1 2 3 4 5 6 7 3, should have this 0 1 2 3. Mid val in this moment is 3, and next to is integer left it's equal nums in the index mid less 1. What is that? In this case, for example, mid less 1 should have this value, the 1, and it's the same with the right. It's in this is plus 1. In this case, if we are here, plus 1 is basically the 5. Okay, and we'll ask mid val it's greater than left and mid-val is greater than right. In this case, return mid-val, yeah, and this return automatically this value here and is stop. Now what happens when don't happen this situation? We need validate the case when it's minor. Well, if now in this case is mid val it's mid-val it's greater than left. Let me change this. If left it's minor to mid-val, when happen this, basically we need pass as a parameter the find integer r it's equal if left it's minor to this, basically if it's minor mid-val, other case is mid-val less 1, yeah, and yeah, and here is find peak element and its nums integer L, and the right is basically this, and for the other is so similar, but the difference is that we need calculate the L because the right, we know that what is the right, in this case is this, and here is basically if mid-val, well in this case is right, it's greater than this, yeah, if this is greater than this, basically we should avoid this value, the 3. Here is mid-val plus 1, yeah, and return plus 1, and here is I don't know how stop this recursion, because this basically all the time return an integer, and yeah, we can apply this operation math.max, it doesn't matter, yeah, between this and this and less 1, yeah, and less 1. Oh my gosh. define pix element, and stop here. But in which moment yeah, nums it's an integer. Index less 1, yeah, because air less L. Okay, let me. Okay, to receive the nums, that is this, and receive L, that is 0. This is right, the final, and the mid is this. Okay, mid value is 3, left is 1, right is 5, and if both are minor to mid val, return the value. In this case is false. Okay, and here is return dot max. Here I'm not sure. Yeah, maybe here it's integer a, it's equal this result, integer b, it's equal this, and return less 1, and here is if a is greater than 0, no, greater equal 0, or b is greater equal 0 to return mat.max between a and b. That's it. Yeah, with this basically, oh my god, he received, for example, the mid val is not greater that is greater than 1 but not to 5, means that the left element is basically all this. I was thinking, because if I send this element, for example, 1, 2, 1, and 3, we know that this is a wrong combination, because this is less, no, yeah, it's a wrong combination, because we know that the next is x. Yeah, we should discard this number. We should discard, because left it's minor to mid val less 1. Yeah, only this. No, yeah. mat.max less 1. Mid is less 1. Why? I'm not sure. Sorry. I will check the Twitch comments. One moment, please. What problem? What? Hello, everyone. Today I complete the test or the daily challenge. Was easy. Yeah, my idea is that the problem is that you have this string and you need to discover what is the number peak element. A peak element is when the neighbors are minor than the element. For example, in this case, the 2 is a peak element because in the left you have a minor value, that is 1, and the right side you have another minor value, yeah, it's another 1, and basically this is the problem. But the complex is that you must write an algorithm that runs in the logarithm n, yeah, and if you try, for example, to validate this number and next to this number and next to this number, well, it's a linear solution. Even if you use 2 pointers, it's the same complexity. It's a linear solution. For this, I have the idea to, let me explain this. My idea behind this operation is basically this. You have the array, okay, and for discover where is the peak element, basically is, okay, you have this element L, right, and the half is this, okay, nice, you have this. The idea is validate. For example, 1 is minor to 3 and 3 is greater to 5. In this case, the first is right, yeah, and this is wrong. Okay, with this information in the first iteration, we know that in this side, yeah, this element don't make sense that exists, because if we move in this section, we in this moment we know that it's impossible create or have this peak element here, because this 3 is greater than the number 1, yeah. For this reason, I have the idea to, okay, when it's okay, basically ignore the current value, yeah, and only have the 1, 2, and 1, yeah. And for example, in this case, when it's wrong, is this, you are sure that this element, this 3, basically you have the half of the answer, you know, because you need that the L should be minor to the current and right should be minor than the current. In this case, for example, when it's wrong, yeah, when the 3 is minor to 5, you have the half of the answer, yeah. In this case is this, you have this half, and makes sense that use all this substring. In this case, 3, 5, 6, and 4, yeah. And my idea is that move using this idea, yeah, with the pointers, obviously. Why I use the pointers? Because basically when you are, for example, in the number 4 or in the last element or in the first, obviously you don't have more elements. For example, here don't exist and here doesn't exist. But the problem mentioned is that when you have, for example, you are in this value, you have, for example, less 1, and here is less infinite. Yeah, basically this is greater. Yeah, if you are here, for example, do you imagine here 1 0 no 0 and 4 5. Yeah, for example here this is greater than this, but no of the this. Okay, this is ignored, but you have this, for example, the 5 is greater than 4. Yeah, and 5 is greater than less infinite, means that you can return this value. Or in this case, for example, if you go to the left side, the 1 is greater than this and is greater than less 1, you can return this value too. Yeah, this is my idea. Now currently I have this code. Basically is that, okay, this is a find pick element, this is the array, the first L, or the first time L it's equal 0, and right it's equal of the length. Yeah, and this is, for example, our test, and receive, okay, the L it's equal 0, R it's equal 1 2 3 4 5 6 7. Yeah, here should be less 1, less 1. Yeah, the last position. Okay, and here L it's equal 0. Yeah, and right should have, oh my gosh, I forget the side. 1 0 1 2 3 4 5 6. Yeah, and is 6 less 0. 6 between 2 is 3, means that you are here. Yeah, the half of this array is this, the mid. Okay, mid have the value of 3, or is in this position, and even I have this. And for get the left is basically mid less 1, that in this case is 1, and mid plus 1 is the right side, this case is 5. And here I have this validation. If the mid half it's greater than left and is greater than right, means that is the answer, and only return this value. Yeah, in this case, for example, the 3 is greater than 1, but it's not greater than 5. Okay, don't execute this return. And here is the recursion, but with the idea, okay, you have the nums. All the time you need to pass the array as a parameter. The L in this case don't change because we are in the left side. Basically we are validate what is the length of this left subarray. Yeah, and the L it's 0. Okay, we start here. Here is L. In the right, we need to validate the right. If left is minor to the mid val, this is minor to this. Yeah, this is minor to this. We need reduce. Yeah, basically we need exclude this value. You know, it's basically is okay. This tree doesn't work with this subarray. Yeah, for the reason appear here mid less 1. Maybe it's not clear here. Let me create a new variables. New right, it's equal. basically equal 0. When the left it's minor to val, okay, this is equal this. In other case, new right it's equal to mid val. No, it's not mid val, it's mid less 1, because we are handle the indices. Mid, yeah, and here is basically new right. Okay, and for the other is basically the same. Mid it's minor to right. Even I can create here another variable, new left, yeah, it's equal 0, and it's very similar here. It's only for don't use the ternary operator. Okay, mid val is minor to right, yes sir, is minor. It's new left, it's equal to mid, that is the indice plus 1. In other case, is mid, no, new left it's equal mid less 1. No, what is air? What is air? Here. It's equal air. Yeah. And here is no. I'm wrong here. When mid val is true, mid val. Yeah. Here is mid plus 1. Yeah, and here is basically new left. Okay, and yeah, I am trying to replicate this algorithm, but here, and basically this, let me move this. The first is left, and next to is the right. Yeah, and here is basically okay. Is calculate the substrings. If the substrings should contains the current value or should exclude. Basically, this is the operation. But yeah, I am. There's 1. Okay, there's 1. Yeah, here I need to consider where is the first element and the last element. Because for example mid it's equal 0 for one reason. Currently we are here, yeah, or R it's equal 0. L I think that it's 0 too. Between 2 is 0. But in this case, for example, start here, and okay, this is exclude, and only we have this, and the half is basically the 2. Why don't return here is mid, because it's the index, not the value. Mid return A. I use this validation because when don't execute or don't found any right index, return less one, a negative value, and basically with this I can note that what is the greater, yeah, where one of both are graded at 0. Yeah, but yeah, I still with the same problem. Mid is less 1. I'm sure that is for the 0, but my question is why don't detect these two? Because the first time, okay, let me copy this code and move here. Okay, now if we have for example the 1 the 1 2 1 3 5 6 4 0 1 2 3 4 5 6, and in this case the first time L it's equal 0, R it's equal 6 because it's 7 less 1, it's 6, and mid it's equal 6 less 0 between 2 it's equal 3, means that we are here. Okay, now this is the value. Mid val, that is 3, is greater than left, yeah, and this is greater, this is the index, and this is the values, yeah, and 3 is greater than 1, yeah, 3 is greater than 5, no. Okay, we create these new variables with 0, and mid val 3 it's minor to 5, yeah, in this case new left it's equal mid, yeah, in mid is 3 is the index. Okay, and now here left is 1, it's minor to 3, no, it's else mid, that is the index 3 less 1 is 2. Okay, now here for the left side is basically nums, that is all the array all the time, and the L it's basically 0, it's still in 0 because in any moment is updated, and the new right is 2. Okay, 0 to 2, basically of this, yeah, and when execute this operation they receive the L is 0, receive the 0, and the right is 2. Okay, and here is mid 2 less 0 between 2 is basically 1, mid it's equal 1. Okay, and this is a comments, and here is mid dot val it's equal a nums in the index mid, that is here, yeah, is the number 2, mid less 1 here it's 1, and the right is 1, mid dot val that is 2 is greater than 1, yeah, and this is greater than 1, yeah, return mid, and here should return 1, maybe I need to put this validation, a simple if a is greater equal to 0, return, because we can remove let me check I am checking the comment. Mm-hmm. Uh-huh. According to this, why isn't the two element peak between? Yeah, is for this validation, the first point is that I get this exception because I try to do all the operation. Yeah, basically here I should. It's not necessary to continue with the operation if a is greater equal 0. Yeah, and here is, well, basically the same, but here is return b. But I'm sure that I will get an exception again. Yeah, because in one moment should be but why because here, for example, in this test, basically we detect that the 1 is a valid number or a peak number, and in this case a have the value of 1 and return a. Yeah, for the first operation return a. Why continue with this value? Let me check if I execute this debug. No, with this test, no. Okay, yeah. Okay, in a it's equal 1. Okay, but yeah, the recursion is not stopped in this moment. Yeah, because I'm sure if I execute again, okay, let me check, because I am I have the idea and it works to find the peak element, but the recursion is not stopped. Yeah, but why? It's not stopped. Why is not stopped? Let me check. Yeah, it's for this reason, because it's working. This code is works, but don't stop the recursion and continue until final. For this reason, in one moment appear here and is 0 less 1 is equal less 1 is invalid. Is an invalid index. But why? Okay, the first time receive the 0, receive the 6. Okay, this is the 3, 3, 1, 5. Yeah, it's basically this and this and this. Okay, myth is greater. This is greater of this, and no. Okay, calculate. In this case, for example, mid val it's minor to right, yes sir, in this case is mid plus 1 is 4, and here is mid is greater than left, yeah, it's mid only 3, yeah, and this receive the number 0 and the right 4, no, the right, sorry, 3, and when go inside them basically it's only, no, why 3, mid val is greater than this is greater, sorry, I am checking the index, sorry, is this 3 is greater than 1, yeah, in this case should be less 1 in here, yeah, here less 1, I still with the same problem. Why? Okay, let me check. Mid val is 3 and right is 5. Here left is 1 and this is 3. Okay. This is true. Yeah, means that the left start here. It's okay. But in this case, 3 is greater than 1. Yeah, we should avoid this 3. Yeah, should we have less 1? Yeah, less 1. But why don't stop the recursion? Why don't stop the recursion? Because in this moment, for example, the first way is for the left here, and when execute this is basically 0 to 2, yeah, in this case the values is 0 plus, no, 2 less 0 is 2, between 2 is 1, mid is the number 2 here, this is our mid, and the left is 1, the right is 1, and this should return the mid, that is the index 1. Basically here return 1, and why don't return this? Why don't stop the recursion? I really don't know what is my issue. Maybe it's for this. It's not. Maybe it's R plus. Yeah. Well, I will try to continue tomorrow. Thanks for watching.